This is Jared Johnson. I'm a systems management architect at Lenovo, focusing particularly on Linux server usage. Uh, Today I'm going to be talking a little bit about Confluent and how it is today. In terms of what exactly Confluent is, it's software to help you manage servers, particularly the hardware level. It can interact with various system BMCs, including the Lenovo xClarity controller and the integrated management module. It can help with tasks such as turning things on and off, setting the boot device, forcing it to net boot, or making it go into the F1 setup menu, managing virtual USB devices, remotely mounted ISOs as virtual USB CD drives, and also to help check firmware consistency and to apply firmware updates, read telemetry such as temperature and power from servers, as well as health checks and event logs, to collect inventory data such as serial numbers, or to collect MAC addresses for feeding into an OS deployment infrastructure, to provide console access and logging. By the end of this video, we'll be showing how to configure systems without knowing their current IP addresses or ever connecting a display to the server itself. So first, I'm going to be storing my preferred password into an environment variable using the bash read built-in. And I'm going to be storing it into the variable called BMC pass, which I will use later. This keeps the password from ever appearing on the command line by, rather than setting the environment variable directly. It's not going to appear in bash history or anything like that. And later, when we use this variable, it will never appear on the command line arguments. Next, I'm going to just go ahead and go to the download page on hpclenovo.com under documentation. We have installing Confluent, and before we begin running the commands, there is the download page. We're running CentOS 7, and so we can use those directions for Red Hat 7. So I'll go ahead and do that here. And I've set up the YARN repository. And now I can proceed doing the recommended steps in the guide. There's just in case there are any updates pending from adding this repository, we're going to go do that and no problems were encountered. We're also going to make sure that this package is installed. Technically, the OS should take care of it, but sometimes some versions of CentOS have an issue with this, so we're going to go ahead and take care of that. And we can finally go on and install the Confluent software. And while that's installing, after it's done installing, then we will enable the Confluent service and have it start at boot. But first, I'm going to skip ahead a little bit. I'm going to be using all the functionality of Confluent, including the web forwarding. So I'm going to go ahead and disable the firewall on this system. There are rules available for more specific guidance for using specific functions. The web interface requires these rules, and the discovery requires these specific rules. But I'm going to be disabling the firewall for the purposes of this video. So I am now going to go ahead and start Confluent. And I am going to be using this to update my path to include the Confluent commands. So at this point, a Confluent command like node list currently will show you nothing at all. So what we want to do is add servers to manage. And we're going to start with the scenario of pre-configured servers. So I have a server. I've already set its IP address and have configured the username and password. So if I go ahead and node define P1 BMC equal 172.33.1, and I'm going to find this system, and then I'm going to use the node attrib command to modify this. I'm going to actually export the BMC pass variable, and now I'm going to node attrib P1 and go and say pull that BMC pass variable into the attribute definition for P1. From that point forward, I can now interact with P1 and do things like get health assessment and power control. Now that's somewhat useful, but there's a capability of doing things at the group level and to do things with kind of more patterns to the infrastructure. So for example, I actually have 10 of these systems and they are numbered 1 through 10. So I'll be able to use that data to make this a little bit quicker to enter. And also there's another group called everything. And this is a default group that exists and will apply to basically every node unless that node has some sort of overriding factor. So I'm going to go here and go ahead and set that BMC password on the everything group. And I am also going to specify that I want to use, in this case, IPMI for the console. And now, if I want to go ahead and define the pre-configuration group, I can make a group called pre-config. The name is arbitrary. I'm picking the name pre-config to explain the scenario. And I'm going to say that members of pre-config have the address 172.30.3.1. So in this particular case, these expressions can have a number of different values. In this example, N1, N2, N3 would be numbers extracted from the name given to the systems. So for example, if I do node define P1 or P2 through P10, since we already have P1 from above, and put it into the pre-config group, we are able to, I did not set the BMC user correctly. So I'm able to run the power command against all 10 servers. And if I look at the attributes for P1 to 10, I can see that the username and password were inherited from everything. And now that we have a volume, we can demonstrate a couple other capabilities. So as I did before, node power P1 through 10, we can do hyphens, or we can hyphenate. We can do the group name, and we can also use this to do some analysis. So if I do node health on pre-config, I'll see that everything's okay. P1 was excluded, but so P1 will have a fault. If you had a number of systems, all those okay results would be a little bit hard to parse through. So there's a collate command to take the output and group it together. So here it shows that P2 through P10 is all okay, and only P1 is the exception with a fault on the mezzanine card. So this will help you interact with systems that have been pre-configured. But what if you don't know what the IP address of the systems are, but you maybe know what you want them to be? So here I have a CSV file with a couple of nodes, and what I'm going to do is I want this to be the IP address of the systems management controller, the Xclarity controller, and this is the serial number that I want to be associated. So if I ping that right now, that IP address, it will not have a response because there's nothing at that location. I can use the node discover command, node discover assign -I, nodes.csv. And what that will do is we'll take that serial number and apply this IP address to whatever has that serial number, and apply this serial number, this IP address to whatever has that serial number. So what I had to do there was I actually requested a rescan of the network, and Node Discover list will show me all the candidates that were available. And after that, I can now ping that IP address because the IP address was deployed by that per that spreadsheet. And this is a fairly common use case of having a ship list with serial numbers and the IP addresses you want them to have, but not necessarily knowing how they're going to be configured. Another scenario that's common is you know how it's going to be connected to your network, but you may not know its IP address. So here I'm going to make another node, and I'm going to call it R1. And I'm going to define R1 as being whatever server is connected. First, I'm actually going to define my Ethernet switch. So I have an Ethernet switch called R8E1. And when I did that, if you'll recall, we set the everything group to include the username and password, admin, and the password for my environment variable. This also applies to the Ethernet switches. So here, the switch is managed using SNMPv3 with the same username and password I'm using for all my Xclarity controllers. So I am now going to proceed to define R1 as the server that is connected to that switch, and I happen to know that I want whatever is in switch port 4 to be called R1. I'm just going ahead and clear the discovery data. And I can check whether that's cleared up in the discovery data. And I can also watch progress in Barlog, Confluent, events. So I neglected to declare my discovery policy. So if I do a node group attrib everything, discovery policy is equal to permissive, and in fact I'll also do pixie. So what this command is going to be doing is opting into the discovery behavior. By default, Confluent will make no changes to configuration unless directed to explicitly by a command. This tells it that it is okay to do so so long as we do not have an existing certificate stored that would conflict. So for adding new systems, this will work. For replacing a system, you'll still get an error saying that you need to approve the change. So after making that change to the policy, R1 came up. And we can do things like boot him into setup. And that will come along presently. Now, in terms of the other systems, I also have 8 SD530 servers in 2 enclosures. So we can do that by describing the relationship of the servers to the enclosures and by describing the enclosures to the switch. So I'm going to go ahead and do this with groups. I'm going to define an SMM group to describe my chassis. And I'm going to say that for an SMM will always be plugged into, in my case, switch R8E1. And in my particular case, SMM1 is plugged into port 1 and SMM2 is plugged into port 2, so I'll just go ahead and use the number of the chassis as the switch port number. And I'm also going to make a group called dense, and I'm going to describe that as the server will go into the will be managed by the enclosure manager SMM, and then I want SMM1 and 2, and so what I'm going to do is say in1, so the first number of the node name, subtract 1 and divide by 4 and add 1. So this is required to make the counting work. So for example, we want 1, 2, 3, 4 all to have SMM1 and 5, 6, 7, 8 to have SMM2. So for the math to work, 1 minus 1 is 0, 0 over 4 is 0, plus 1 is 1. And we get to 4, 4 over 4 would have been 1, but because we subtract 1, 3 over 4 is still 0, plus 1 to still be an SMM1. And then we get to the fifth node, 5 minus 1 is 4 over 4 plus 1 is 2. So that is why we have this subtract 1 and then add 1 at the back. And similarly for the bay, we're going to do n1 minus 1, divide by 4 and take the remainder. And so now I have a dense group and an SMM group, but I don't have any nodes defined to belong to those yet. So I'll go ahead and define 8 systems and put them into the dense group. And I am going to define 2 SMMs, and I'll put them into the SMM group. And I'm going to clear and rescan. I'm just going to double check whether this worked out right. Switch RAE1, switch port 2, and I'm going to check the discovery policy, which should be inherited from everything. And I can look at the events. It's a little slower than I would like. I'm just going to an abundance of. All right, so this time I think I was on the wrong end of particular timing between setting the attributes and these appearing. So now I can node power D1 through D8, and I can, for example, boot D3 into setup as well. And if I, for example, node console R1, I can see the F1, the configuration menu for R1. And if I look at D3, I can see its boot process proceeding. I can also, at this point, set up the web interface. So one, if you still have SE Linux enabled, you have to tell SE Linux that it is permissible for Apache to connect to other services. We've already disabled the firewall, so we do not have to do the firewall command. Here, we can create a demonstration user with that particular password. There are other ways, but for now, we'll do this. And we're going to make sure that the web server is actually enabled and started. Now we can go to the server. Apply.lab.lenovo.com. I'm going to go ahead and proceed. So demo user is the username that was created here, and that was the password at the time. And here are the systems that we've been adding. So if I did, for example, D1 through D8, I can then proceed to open multiple consoles and fit them to screen. And here we have, for example, D3 system. And if I want to see it a little bit better, I can bring that up. And I can also use this in conjunction from the command line. So if I'm connected to D3's console through node console command, both terminals are aware that the other one is connected, and as many as connect are able to freely interact with the set menu. Additionally, if I want to access the XCC of D3, I can do so. Now, what may be interesting is that for N1 and N2, you may remember that I specified an IP address. However, for the rest of them, I did not. Now, I could have, and it would have deployed those IP addresses, but as it stands, I can actually go in, for example, here, and I see that this is the current IP address, but I can set to whatever I want. And I won't lose connectivity. I will be able to continue to freely access this web interface despite the fact that the network address has been changed, because Confluent's connection to D3 is a little bit more robust and would stand up to this sort of mistake. And in fact, I can use the node config command to see the IP address and in fact change it back to something a little bit more usable. For example, 186.3. We should see that it will come back and not have any return. IPv4 address equal 172.30.86. And in this context, we are actually able to use the same sorts of expression. And now we've just used node config to deploy an IP address to D3. And presently, when the configuration takes effect, these will be replaced with the ping actually coming back successfully. And there it is, the change has taken effect. So this is a good way to make sure you have a way in to correct network configuration or change the network configuration freely without having to worry about whether things are currently correct or not. What happens behind the scenes is that Confluent recognizes the situation and grabs the more resilient IPv6 link local address and uses that for communication. And so that's generally how to get started and going with Confluent, whether it's just to manually remember some systems, as I did with the pre-config case, or to do more sophisticated things like use group membership to apply patterns, or to use a spreadsheet to deploy IP addresses to systems, or to bring systems under management based on how they are physically connected.